Okay, welcome to another episode of Ty Does Maths. This is the predicted paper for this year. It says November 2022 on, but it was a predicted paper that I downloaded and it was from Maths Genie. So we'll see what this is all about. Let's have a quick go. It says 1 hour 30. It is a guess at what's going to be on the paper 1. The predicted papers for paper 2 and paper 3 will be better because obviously in maths anything can be tested, can't it? So right, here we go. We've got 37.1 times 9.3. So the traditional method of multiplication is just the column method, but I'm going to do this another weird way. It just looks like this thing. We're going to do three. I'm going to do 3 boxes, and then 2 boxes going across because it's 371 and 93. So I'll write like this. I'll put diagonal lines in, but this is based off Napier apparently, a Scottish mathematician. Here we go. 3 9s are 27. 7 9s is 63, you just fill in the 6 and the 3. 1 9 is 9, so you've got to put a 0 there and then a 9. 1 times 3 is 3, so 0, 3. 7 3s are 21, and 3 3s is 0, 9. So I get all these numbers filled in the grid, quite easy. Notice I've forgotten the decimal point, because that's what you do when you multiply decimals. Forget the decimal point, just multiply. Add up the diagonals, so you've got 3 for this one. 9, 0, 1 is 10, so you put on 0, carry 1, just like you normally do in normal addition, where you just carry the next the 1 round. 0, 3, 4, 5, 6, 15, 5 down, carry 1, 7, 6 and 1 is 14, 4 down, carry 1, 2 and 1 is 3, and there's our answer, 3, 4, 5, or 3. Okay, and then the next thing we've got to check is the decimal point. So we've got 1 there, we've got 1 there, so we need 2 decimals in our answer. 1, 2, put the decimal point in, make sure the decimal point's nice and clear, because sometimes when I mark mine, some people put on the line and then it just disappears. 72 is a product of prime factors. I like to do this starting with 2, so 2 times 36. I like to put the times sign in the middle as well. 36 is 2 times 18. 18 is 2 times 9. 9 is 3 times 3. And that's the end of that story for multiplications. Then we just look at the numbers that are by themselves at the end, and we can write down here product of prime factors, so we don't have to do any fancy things. It's 2 times 2 times 2 times 3 times 3. Big mistake is putting commas between them. That happens quite a lot. Don't do that. It's a product. Product means multiply. So we should be able to see multiplications. And prime, product of primes, these are all prime numbers, not 9. The other way to write this one is 2 squared times 3 squared, 2 cubed, sorry, 2 cubed times 3 squared. Personally, I prefer this version because it's a lot more easier to interpret this one than it is this thing. Okay, so I prefer this version. Next question, number 3. So we're ordering a pizza for all the people in the company. Sam takes a sample of 50 people in the company. She asks them what's pizza like. So there's 50 people in the survey. The table of information below. So we've got 600 people actually in the company. Work out how many pineapples. So pineapples, this one. So out of the table we've got 8 out of 50. And the thing we want here is the same fraction in the 600. So we've got 8 out of 50. What I'm going to do here, we could say 8 out of 50 of 600. Let's do that. Of the 600, it's going to be that one. So we do 600, we divide it by 50, and we multiply by 8. 50 goes into 600 12 times, so that's equal to 12 times 8, and 12's 8 are 96. Write down an assumption that you made and explain how this could affect your answer. It's just a 1-point question. I assumed the same proportion of people in the survey, in the sample. It's called sample because that's the word it used. I assume the same portion of people in the sample and in the company. I spell company. Would like pineapple. Like pineapple. It could be more or less. Okay, so more or less people could like it, but we just assume it's going to be the same in the sample. So that's 1, 2, 3. Number 4, we've got in a bag there are blue sweets, red sweets, green sweets. The ratio of blue, red and green is 5, 3, 2. What fraction of green? Well, if you look at this thing, we add them up together. We have 5 and 3 and 2 is 10. So 5 plus 3 plus 2 equals 10. And of the green sweets, blue, then red, then green. So we're looking at the 2. It's just 2 out of 10, like the green sweet. Now we don't have to cancel this down. It doesn't say simplify the fraction, so 2 out of 10 is fine. Could cancel it 1 out of 5, but who bothered about doing that one? Getting these things, adding fractions, or adding and taking away fractions, you've got to get the bottom numbers the same. It doesn't say anything about simplifying the things, so I'm not bothered about the simplest form or anything. One quick way is just do 4 times 10 is 40. Now I like to put the 40 on the bottom of the whole fraction, put the take in the middle, and then to get from 4 to 40 I multiply by 10, so I multiply 3 by 10, I get 30. And then to get from 10 to 40, you're multiplying by 4, so 4 sevens are 28, and that's going to give me 2 out of 40 as an answer. Now obviously I could have went to 20 because 4 and 5 go into 20, so I do know that. This does cancel down to 1 over 20, but it doesn't say anything about simplifying. If it doesn't say simplify, don't simplify. Okay. Next question does say simplest form here. Now multiplying multiplying mixed numbers, you've got to get the mixed number into an improper fraction. And that's just the big times the bottom plus the top. So 2 times 3 is 6, plus 1 is 7. So we've got 7 over 3 multiplied by 3 over 5. And now what we can do now, we can actually cancel before we do the multiplication. Or we can just go ahead and multiply. You know, it does say the simplest form, so I'm going to cancel before I multiply. So 3 goes into 3 once, and 3 goes into this 3 once. In multiplication, you can cancel anything off the top with anything on the bottom. And that's where I'm going. And now I'm going to do multiplication. So 7 times 1 is 7. 1 times 5 is 5. And then 5 goes into 7 once, so there's 2 left over when I do that, and I was dividing by 5, so it's just 1 2/5 as the final answer. If I did the multiplication, I would have ended up with 21 over 15, and then I would have probably went to a mixed number, then cancelled the fraction down as a third step, but you just cancelled early. Number 6, PFA. So I like to have the PFA triangle, so pressure, force, and area, so I like this PFA triangle. A block exerts a force of 84, so F equals 84. We've got pressure, where am I going to put the phone? Pressure equals 112, so we've got these two things. And then we're working out the area of the box that's in contact with the table. So area, if you look at our little triangle, area is just the force divided by the pressure, force on top. So area equals force divided by the pressure, in which case area equals, force is 84 over 112. And we're happy with that one because it doesn't say anything about simplifying anything down, so we're happy with that number. You could simplify down, I guess, so what's that? It's going to be 42 over 56, and then 42, 21 over something, and then something else. It just cancels down like crazy, doesn't it? But nobody's saying cancel down, so don't bother. 84 over 112 will do it. Next one, Andy and Bruce share some sweets in the ratio 9 to 4. Andy gets A sweets, Bruce gets B sweets. Carl and David share the same amount of sweets as Bruce. They share their sweets in the ratio of 5 to 2. Carla gets C sweets and David gets D sweets, and find the ratio A, B, C, D. So that's horrible. So let's go with the ratios. So we've got Andy. He gets 9, let's call it N. And then Bruce gets 4N. Okay, so we've got that one. So the total number of sweets is going to be 13 times some number. That's the total number of sweets. Okay. Carl and David said they share the same amount of sweets, so there's 13N, and they share the sweets in this ratio of 5 to 2. Okay, so 5 to 2, we've got 5 plus 2 is 7, and then you've got 13N divided by 7, so that's just over 7. Is the next step you do for sharing them out. And then Carla gets 13N over 7, 13N over 7 times by 5, which is horrible. So what's that? That's 65N over 7. And then the other one, David gets 13N over 7, and then you've got times by 2, which is 26N over 7. So there's David's. So if we put them all together, we get a 9N plus, ratio 4N for Bruce, and then the ratio we've got for Carla is 65N over 7. 65N over 7. And then ratio for David, we're going to have 26N also over 7. Now I'm going to multiply these two by 7 and multiply these two by 7, so the 7s will go away. We're going to get 63N to 28N to 65N to 26N, and then I can just divide everything by N now to get the final ratio of 63 to 28, 65 and 26, and that's the ratio I'll finish with. So when you don't know how many sweets you are to start with, then all you're doing is you're multiplying by n to get the total number of sweets that Andy gets and Bruce gets. Okay, so that's number 7. Bit of a horrible question, that one. Number 8, just a, what's this one? Rotation. So normally I would have tracing paper here. I'll just show you how this one works. So you put your tracing paper here, you would then trace your shape, stab the tracing paper there, and then just spin this 180 degrees, so it's going to end over here. Okay, so I'm going to pretend I've got tracing paper, so I'm going to take the tracing paper from there to there, and I'm going to run this 180 degrees, it lands over there when I go 180 degrees, and then what's happening with the shape, it's going to turn upside down, so it's going to go 1, 2, 3 across, 1, 2 upwards, 2 down there, and then across to there. So that's going to be what the rotation looks like, and it says label it point A, so I'm going to label this one A. Okay, not sure that's in focus very well because it's hard to read. There it is. Okay, that's better. Okay, translate T by the vector -1, 3. So vectors mean go across and go upwards. Now this one's obviously going backwards 1, and then it's going to go down 3. So you pick any random point to start with. I normally pick the bottom left corner, see where that goes, and then I can draw the shape. So I'm going backwards 1, down 3, 1, 2, 3. So that corner is ending up down there. So from there, I can go like this and draw the shape in. Now it wouldn't matter which, I could label this one B. It wouldn't matter which point I picked, that would end up the same when 1 across and then 3 down, or 1 backwards, 3 down. So that's all the vectors mean. Translate just means move it. Rotate, obviously spin it round. Number 9, let's look at number 9. We've got some sort of multiplication, and this is where I don't like when you've got the numbers with the indices. So I'm just going to write them out again. So A is actually 2 times 2 times 3 times 5 times 5. Says A. B is 1, 2, 3 2s, whoops, 3 2s, times by 2 3s and a 7. Now the way we do these things is, one way is to do a quick Venn diagram, so you put big circles, this is for A, this is for B, and then what's going to go in the centre is anything that's in both of them, so we can get 2 2s and a 3 out of both of them, 2 2s and a 3, so we can go a 2, a 2 and a 3 in the middle, and then A's got 2 5s, B's got a 2 2, a 3, a 2 3 and a 7, 2 3 and a 7. And then when you're looking at the highest common factor, it's the middle section is the highest common factor. So that's the middle section. So HCF is equal to 2 times 2 times 3, 4 times 3. That's just equal to 12. So the highest common factor of these two numbers, which we don't know anything about, is 12. Well, we know everything about them. The lowest common multiple is where you multiply each of the groups. So this first group is 5 times 5 is 25. We already know this one's 12, so we times them by 12. And then we multiply them by 2 times 3 is 6, 6 7s are 42, so this is going to be quite horrible. 6 7s are 42, yeah. 12 times 25, well 4 25s are going to be 100, and then you've got 3 4s in there, so that's 300. So it's equal to 300 times 42, and then you've got 3 times 42 is 120, 126, 126, and 2 more zeros to kick into play, and there's the number there. Notice I'm not really moving that over here. I see too many people write the correct answer here, then when they transfer it over, they write the wrong answer down here. You don't need to. The examiners will find where you've put the answer, as long as it's nice and clear. Okay. Next one, S equals ut plus half at squared. This is one of the SUVAT formulas which the A-level people used to use all the time, but now it's been snuck into GCSEs just to make it fun. Now the way I do the way I substitute into formulas, I just take all these letters off and I'm going to put brackets there instead. So I've got S equals, and I've got a bracket for the U, a bracket for the T, plus a half, a bracket for the a bracket for the T, and then I've got a squared. So there's my formula without the letters A and T in it. And now it's just a case of filling in the numbers. So U is -5, UT is 3, half A is 4, and then T is 3 again. And then you've got the squared button. Okay, so now I just work this out. So I've got -5 times 3 is -15, plus a half of 4 and 3 squared. Now I've got to do the squared bit first, so that's 9. So that's going to be 9. Half of 4 is 2, and then 2 times 9 is 18. So that's that one, and then this thing turns out to just be 3. If you're interested, S in A-level maths is how far you're travelling. U is the initial speed, T is your time, A is your acceleration. So it's moved 3 meters, I guess, if it's usually in meters per second. Number 11, let's have a look. Sweets are sold in small packs and big packs. There is a total of 175 sweets in 4 small packs and 3 big packs. Let's write that. So you've got 4 small plus 3 big equals 175. And then the next one, we've got 5 of 154 in 5 small packs plus 2 big packs equals 154. And this is just a simultaneous equations question. Now the way I do simultaneous equations might be slightly different to everybody else. I just multiply these to get these two to be the same number, do a takeaway, figure out what B is, sub back in, get S. So here we go, I'm going to multiply this row by 5 and this row by 4. 5 times 4 is 20S, must multiply everything. 5 times 3 is 15, so plus 15. B, oh this is going to be horrible, equals, and then 5 times 175, which I don't know off the top of my head, so I just do it over here. Times this by 5. You get 25 there, 2, 5, 7 to 35, 37, 3, and 5 and 3 is 8. So it's 875, And then the next one, multiplying this lot by 4, you get 20s again, which is the target to get these two the same, plus 8b's equals, and I would need 454s. Well, just forget about the 4, you got 4 150s is 150, 300, 600, and 4 4s are 16, so 616. Next thing is this take away, so just do a take away, so that one's going to go away. 15 take away 8 is 7b's equals, and then this one take away this one is, let's go, we've got take that to a 6, 15 take away 6 is 9, 6 take away 1 is 5, and 8 take away 6 is 2, so we've got that number. Divide this by 7, so B is equal, now I'm just going to pretend there's a bus stop over the top of this one, so it doesn't go into 2, it goes into 25 3 times, that's 21 carry 4, 7 into 49 is 37. So B is 37, so the big pack turns out to be 37. And the small pack, what we do is we stick this back in the original question, so we get 4s plus 3, lots of 37, equals 175. So 4s must equal, and that's going to be 90 plus 21, 90 plus 21, where's equals gone, plus 90 plus 21 is 111, equals 175. So 4s's must equal, take 11 from that one, or 11 from the 75 because hundreds will cancel, so that's going to be 64, and then s must equal 16, just divide them through by 16. Now you can do a quick check, you can sub this into the original equation, let's try that. So 5 lots of 16 plus 2 lots of the 37, what's this equal to? Well, 5 16s are 80, plus that's going to be 74, and this thing is 154, which is what it says up there, so this must be right, so we must get 3 points because everything turned out to be correct. Next one, 3 times root 27 equals 3 to the n, work out the value of n, so we're going to notice 27 is cubed, the square root is a power of a half, and then you've got 3, which is going to be the power of 1, so let's put that in. So we've got 3 to the power of 1 for the 3, times by, and in brackets, 27 is 3 cubed, and then you've got a square root sign, which is a half, okay? And this thing, when you've got brackets, you just multiply these two together, so that's 3 to the 1 times by 3 to the 1.5, let's go with 1.5, or we could have 3 over 2, but it's just easy to see that way. Then multiplication is add the powers, so add these powers, 3 to the 2.5, and then you've got 3 to the n, n equals 2.5, okay? So it's all about knowing about numbers there. 12, number 13, we're going to draw a graph. Okay, so non-calculated paper, so let's work it out. So where we do substitutions is we just take off a letter, set up the equation again, plus 3 lots of something. So that's our y value, so y equals that. And then we just run the numbers. Now when you run the numbers, I always like to start from this end in all my graphs. So I start this end and I'll get down the negative numbers eventually. So I'll put 2 in here, so imagine there's a 2 in there. And I've got 2 for 8, so it's going to be 8 plus 3 2s are 6, so it's going to be 14. When I put 1 in here, I'm going to have 1 cubed is 1, 3 1s are 3, so it's 1 plus 3, which is 4. Putting 0 in there and 0 in there is going to give me 0. Putting 1 in here, so minus 1 cubed is actually minus 1, because minus 1 times minus 1 is plus 1, and then times by another minus 1, you get to minus 1. Plus 3, let's have a plus 3 lots of minus 1 is minus 3. Now this plus and a minus here becomes a minus. Minus 1 take away 3 is minus 4. And you've got to be careful, you know what that looks what that is, so plus and a minus. And then the same with minus 2, so minus 2 cubed is minus 8, and minus 2 times 3 is plus minus 6, and then these two make a minus 8, take away 6 is minus 14. Plot those points on the graph, so we've got 2 and a 14 up here. Make sure you look at your scale at the side, so this is a 2 here, so that's 4, 6, 8, 10, 12, 14. And then we've got 1 and 4, 1 and 4 is here, 0, 0, 1 and minus 1 and minus 4, minus 2 and minus 14 all the way down here. And then when you're drawing a graph, any sort of cubic or quadratic is a curve, so don't draw these with straight lines. So draw a nice little curve going through, try to hit your points. Was a little bit off that one, but sort of fudged it in. So there we go for drawing a graph. So 4 points drawing graphs. Number 14, we've got some sort of probability thing going on. We've got in the bag the red counters, blue counters, green counters, yellow counters. A counter is taken from the bag at random. The table shows a probability the counter will be green or will be yellow. Okay, so at the moment I can see 0.55 there. 0.55 is what I'm looking at. So this must be 0.45 missing here. So let's see what else have we got. We've got the probability the counter is red is twice the probability the counter will blue. So if we just look at this number here, so it's come to my head that's going to be 0.15. The red is twice the probability of the blue. So we've got if the probability of red, if P of the red is twice the probability of blue, is 2 times the blue, and the probability of blue is just equal to B. Then 3b, the total probabilities of these two, equals 0.45, and so B must equal probability of blue must be 0.15. So blue is 0.15, and then red must be 0.30. Okay, it is 0.3, but 30 and 0.15 look like 0.45 to me. One more total next. The probability of the counters, there are 21 green counters in the bag. Now 0.35, so 0.35 represents the 21 counters, so that's equal to 21 counters. 0.35 gets me the 21 green counters. Is this even going to work out? So in order to get to such 21 green counters, in order to get to the number of red, which is 0.30, I reckon if I divide this by 7, oh, that'll work, won't it? So I'm going to divide by 7 to get to 0.05, 0.05, and then I'm going to multiply by 6 to get 0.30, which is our target. And then if I do the same with these numbers, so it's divided by 7 you get 3, times it by 6 you got 18, so there's 18 green counters in the bag. Okay, red counters, sorry, 18 red counters in the bag. That's all that one was, so a little bit complicated. Number 15, all measurements at the area, so we're looking at an area of a rectangle. The way you work out areas, you multiply these two together. So we've got 2x plus 3 multiplied by 3x minus 3. That's how you work out area of a rectangle. That's width times height. And we're told that's actually 75, so I'm going to put equals 75 there. Multiplying this out, I've got whichever method you're going to use. I use a smiley face. So I've got 6x squared there. I've got minus 9 there. I've got 9x here. And I've got minus 6x there. And these two give me 3x's. So if I look at that, I've got 6x squared minus plus 3x minus 9 equals 75. Now I'm going to just divide everything here by 3 because I can. So I'll just simplify it down a bit. So 2x squared plus x minus 3 equals 25. I'm going to bring the 25 over here and see what's going on then. So 2x squared plus x minus 28 equals 0. Now I'm trying to solve this, so I can either run it the formula now or I can try a factorising. I'm probably going to try a factorise and see if that works first. So the way I factorise these things is I do multiplication there, you get minus 56. 2 times 28 is minus 56. You've got to break this down, break, make, check. So breaking 56, I get 156, 2 28s, 3 doesn't go into 60, that 4 does. How many times 4 going to it? 15, 14 times maybe. 4, 5, 6, 7, 8 make 56, and then that's it. To make 1, I can only use it with these two. The way I make 1 is doing plus 8 and a minus 7. So my next step for this thing is to set up the equation, the quadratic, with the 2x inside on both of them. So this looks a bit different. Someone showed me this once and I thought it was really good. So 2x and 2x there. but there's too many 2s, so you put 1 over 2 here, and then you put the numbers in, so minus 7 and 8, and then you need to get rid of a 2, so that's plus 8. You need to get rid of a 2, now I can take total of these 2, so I put a 2 there to cancel off this half, and then this is equal to 0 over there. So we've got 2x minus 7 and x plus 4 is the factorization. The solution of this thing is when this equals 0 or when this equals 0. So if this one's equal to 0, then add the 7, divide by 2, x equals 3.5. If you put this equal to 0, x must equal minus 4. So there's your two options. Now what you do is you look back at the equation, the setup, and you just check both your answers are valid. Now 3.5, if x is 3.5, this is going to be 2 lots of 3.5. Let's write that down. So 2 lots of 3.5 plus 3 is 7 plus 3, which equals 10, so that's okay. And if it was minus 4, I'd have 2 lots of minus 4 plus 3, minus 8 equal minus 8 plus 3 equals minus 5. Now this thing doesn't make any sense for the setup. You can't have a length of a rectangle being minus 5, so this doesn't make sense. This answer, it is an answer, but it doesn't make sense in this context. So the actual answer to the question is x equals 3.5. Show the value of x equals 3.5, not the minus 4. Okay, so you've got to look back at your context. Not that. Number 16, proportion of bacteria is increasing 10% per hour. The percentage increase of the population find the percentage increase every 3 hours. Okay, every 3 hours, that's a bit weird. So we'd have, so it's increasing by that one, so we'd have 100% plus 10% equals 110%. So the population will be multiplied by 1.10 to the power of 3 for 3 hours. And if you put this to the power of 3, what have you got? You've got, that's a bit hard to work out, 1.10 times 1.10 times 1.10. Right, if we just pretend this is 11 to kick off with, so we've got 11 times 11 times 11, 121 times 11, which is equal to 1210 plus another 121. So that's 11 of them, so that's 1331. So this thing, when you're multiplying this lot, I'm thinking it's going to be 1 point is equal to 1.331. I'm thinking, and therefore the answer must be 33.1%. 33.1% is how much it's increased by after 3 hours. Because it would be like 10% every hour, wouldn't it? But it'd be a bit more because you're increasing the percentage of increase to the first hour. It gets increased as well. Right, this mess, let's have a look at this one. So we can do a couple of things here. We can just go straight forward and expand the brackets, but that's going to be 8 times 18, which I'm not going to fancy doing. I guess we could do that, couldn't we? 144, something like that. No, let's just do that, I think. So we've got smiley face job. So 3 times 5 is 15. Minus 8 times minus root of whatever 18 is the square root of, and 8 times, let's just double check that, 8 times 18, 144 is my guess, 8 8 is 64, 6, yep, 144, so that's alright. So 144 in there, and that's going to be quite nice, that's going to be just 12, isn't it, the square root of 144. Underneath here we're going to have minus 5 root 8, and underneath that one you're going to have 3 root 18, okay. So far I've got this thing's equal to 15, minus the square root of 144, which I know is 12, minus 5 root 8, and then I've got plus 3 root 18. Now that thing is equal to 15 take away 12, which is quite nice. 8 is equal to minus 5 times 4 times 2, and I like to put the square number at the beginning, plus 3 square root of 9 times 2. Now I knew there was going to be something to do with 2's because it says here it's got to be a 2, right? So 2 must go into both the numbers. This is equal to 15 take away 12 is 3. Take away 5 times, and then 4 root 2, square root of 4 root 2 is the same as the square root to be 2. So 2 root 2 plus 3 times by, and that's going to be 3 root 2's in that one. Okay, and that's going to be equal to 3 minus, this is 10 root 2's plus 9 root 2's. And then you've got equals 3 minus 10 plus 9 is minus 1, so minus 1 root 2, which is a bit ugly because it should be 3 minus root 2. From here we can see A must equal 1, A must equal 3, sorry, 1 I'm not talking about, and B must equal minus 1. Okay, you can see it more clearly there, but we would write like that one anyway. 17, 18, sketch a graph of this thing. So the graph of sine x goes up and down to 1, so and minus 1, so there's 1, there's minus 1. It starts at 0, it goes up to here, and then it gets down to there, then it gets down to a minus 1, then it gets to there, and it's just a nice little curve going up, hits the point, come back down, hits that point, a bit rubbish there, and then curves around that one, and up like that. So it looks something like this thing, just a sine wave. Adding fractions, sorting this out. So what we're going to do, I'm going to cross multiply, and then I can just leave these two together. So I've got 8 into x plus 1 plus 6 into 3x minus 2 equals 2 over this side, and on the bottom I've got 3x minus 2, and I've got x plus 1 as our multiplication. We can multiply this out, so we get 8x plus 8 plus 18x take 12, that's 6 lots of 3's and 6 lots of 2's, 18 and 12. And on the bottom, let's expand that out, because we're going to need to when we bring it up here anyway. So we're going to have 3x squares, we're going to have a minus 2 at the end. Underneath we're going to have 3x, take away 2x's is just going to be an x, so plus an x equals 2. I'm going to simplify this thing, and I'm going to multiply that one over there. So we're going to have 18 and 8 is 26 x's. 8 take away 12 is minus 4 equals, and multiplying everything in here by 2 on this side. So 2 lots of 3 is a 6x squared plus 2x minus 4. Next step is to get everything onto one side, so we have an equal 0. So we get 0 equals 6x squared. 26, take it off there, you get minus 24x, and then the minus 4 on this side becomes a plus 4, and that's going to wipe that out, which is going to be quite nice. This thing will factorize, equals 6x into x minus 4. I could have just divided everything by 6 to make it simple. Equals 0, and therefore either 6x equals 0 or x minus 4 equals 0, so x is equal to 0 or just 4. Okay, divide everything by 6a, you get x equals 0, bring the 4 across, you get the 4, x equals 4. That's that one. Right, number 20, calculate the length of the arc. So the arc's part of the circumference equals pi times diameter. Now in this question you've got the radius equals 18, so the diameter must equal 36. Now the fraction of the circumference that we've got is going to be 125 out of 360, so we've got 125 out of 360 times by pi times the diameter times 36. Okay, and put times there because you're not ready for the dots. So that's the length of this arc AB, and then what we can do is we can do the divisions. So we can say 36 and 360, they'll divide, so 36 goes once and goes this one into 10 times. So that's going to be 125 times pi divided by 10, so 125 pi divided by 10, I'm going to put 12.5 pi. Okay, just 125 divided by 10 is 12.5, then leave it in terms of pi. Inverse proportion, so we've got x is something, k proportional, inversely proportional to, so divided by square root of y, square root of y. So we set up this little equation to start off with, a little formula. When x equals 12, y equals 9, put numbers in, so 12 is equal to k over the square root of 9, and the square root of 9 is 3, so 12 equals k over 3. Multiply this side by 3, 36 equals k. Set up your equation, so go back to the top and say, okay, so x is equal to 36 over the square root of y. And this is the formula we're trying to get to. Find the value of x when y equals 81. So now x equals 36 over the square root of 81, which equals 36 over 9, which equals 4. Okay, so it's all, the inverse proportion is something divided by, we just write k over it, and then away we go. Number 22, what's going on here? So find the size of the angle ABC. A to B is C. So I'm looking for this angle down here, aren't I? Right, so first thing I'm going to do is I'm just going to draw this radius in, 0 to C. what that's going to give me, you must show you're working out. So working out is different to reasons. Working out just means give all the answer, all the stuff. So this thing here must be 90 degrees because the radius and the tangent always make 90 degrees. This angle down here is 29 degrees, okay, because it's an isosceles triangle. This is a radius and this is a radius, and that makes it an isosceles triangle, so the base angles in isosceles triangles are equal to each other. We're trying to work out A to B to C. We're trying to work out this angle, aren't we? Well, now if we look at our triangle, we've now got this big massive triangle here, like this thing, where we've got 29 in this corner. These two added together are 119, and then we need this angle here, which obviously needs to add to 180. So we add these two together, 119 and 29 is 8, carry 1, 4 and 1, 148, and then 180, take away 148, equals 32 degrees for our answer in the triangle. So that's that angle there, number 23. It's got some formulas here which we're probably going to use at some point in this question. Oh, that seems to have gone blurry again. Let's just adjust this a little bit so you can see what's happening a little bit. A little bit better, not brilliant. Height of the cone is 12 centimeters. The base of the cone has a diameter of 10, so the radius is going to be 5, which you always want the radiuses of 5, and that makes this height here 5 as well. To work out the total volume of the shape. Okay, so the volume of the cone is 1/3, leave your terms of pi. So the volume of the cone, is 1/3 pi. The cone's got a radius of 5 squared times by, oops, don't like that one, times by 12 the height. So that's the volume of the cone. Let's work that out. So we've got 1/3 of 12 is 4. So we've got pi times 25 times 4, and that's 100. 5 times 25 is 100 pi. So there's our volume of our cone. Our hemisphere, which is half a sphere, is going to be, so volume of the hemisphere this time is equal to 4/3 pi. R is 5, remember, cubed, and then we want to times this by, times it by 1 half that one, so basically times by a half, or you can divide by 2, which is the same as times by a half. What can we do here? So let's have some cancelling somewhere. So we can cancel the 2 there with the 4 to get 2 and a 1. So 2 goes into a 1, so it goes into 4 twice. So we're going to equal 2/3 pi. 5 cubed is 125. Oops, why have I put 15? 125 times by 125 times by 1 is gone away. That's 5 times 5 is 25, and 5 25s are 125. We can do 2 times 125, which is 250 pi over 3. So there's the volume of the hemisphere. Total volume of the shape is just these two added together. So now we want 100 pi plus 250 pi over 3 is our final volume. We can tidy this up a little bit just because we're going to show off. Put this over 3 makes it 300. So it's equal to 300 pi plus 250 pi over 3, which is 550 pi over 3, and we'll leave it like that because we don't want to try and cancel that down. It doesn't divide by 3, and I don't want to go to mixed numbers. Histograms, I love histograms. I think they're just big rectangles, and the big rectangles, it's all about the area of a rectangle is the frequency. So you've got the width and you've got the height, which has got this posh name called frequency density. 30 pigs each way, 30 pigs weigh between 50 and 65, so where's that one? Between 50 and 65, so we know that there's 30 pigs in here. We know it's 15 wide, so if that's 15 wide, then this must be 2, which means we're going up, so that's 1, that's 3, that's 4, there's 1, 2, 3, 4, there's 5, and there's 6, there's 7, and there's 8, okay? Let's just put everything else in there. So we've got in this box, that's 5 wide, 6 tall, 5 times 6 is 30, it's just a rectangle. 5 times 8 is 40 in this one. We've got, what's this one, that's 10 wide, so there's actually 40 in here. And then this one is 15 wide, 1 tall, there's 15 in that one. So we've got lots of things going on there. Work out an estimate for the number of pigs that weigh more than 80. So 80, if we just put a dotted line where 80 is, so we've got half the 40, so we've got 20, and then we've got these 15 as well, so that's just 35. Explain why your answer is only an estimate. Is because we don't actually know how many are in between the 80 and 85. All 40 of them could be this side, who knows? All 40 pigs could have weighed 78 kilograms, who knows? So that's why it's an estimate, because we don't know exactly how many between 80 and 85. So let's write that down, because we don't know how many between 80 and 85. Okay, that will give me a point. That's what the estimate is. Where are we at? Number, oh, done that one, so it's 25, there's another one on the back. We've got, he's going to take a card at random, she does not replace the card, okay, so that means the probability is going down, it's probability question, isn't it? Yeah. Helen then takes another card at random, calculate the probability of the card, that the number on the second card she takes is greater than the number on the first card she takes. Oh, that's an interesting question. So, calculate the probability she takes a number on the second. So the first option is, so she gets a 1, and then she must get a 2, or she gets a 1 and she gets a 3, or she pulls out a 2 and a 3 and a 3. Oh, well, they're the only options, isn't it? She can't do anything else. Calculate the probability the number on the second card Helen takes is greater than the number on the first card she takes. So that's the option she's got. She only have these options. The probability gets a 1 on the first round is going to be 2 out of the 7 cards, out of 7 cards. Then the probability she picks a 2 next is times by 2 out of 6, because she's already taken a card and she didn't put it back in, so it's now out of 6. Or in probability means add. Get a 1, that's 2 out of 7. And the probability gets you 3 is times by 3 out of 6. Or she picked a 2, which has got a probability of 2 out of 7, and then probability she gets a 3 times by 3 out of 6. Okay, this is going to be 4 plus 6 plus 6, and they're all out of 42, so put them all over 42, and then you get your answer. 10, 16 out of 42 is the probability that I'm going to go with, and you never cancel probabilities down, or very rarely do we cancel probabilities down, so leave it there. Number 26, work out the value of x. So what are we doing here? Oh, okay, so we've got, oh, look at this, it's a horrible thing. And it looks a bit like the sine rule. Now my version of the sine rule is a sine b equals b sine a. That's the version I go with. I don't like this a over sine b equals, no, a over sine a equals b over sine b equals c over sine c thing, or the other way around, whichever that is. I always just like that version. So we're looking for this one, aren't we? So I'm going to call this one capital A, this is going to be little a, this is going to be capital B, and this is going to be little b, so definitely the sine rule. Let's fill the numbers in. So we've got A, which is x, so we've got x sine 45 equals B, where's B? So B is 8 sine of A, which is 60. So this question now is asking me what's the exact values. Now a quick way to do the exact values is a little table. So there's a table here where we've got the angles we're supposed to know are 0, 30 degrees, 45 degrees, 60 degrees and 90 degrees. They're the ones you need to know. We've got the sine and the cosine underneath, which we don't really need. And then you just go 0, 1, 2, 3, 4. And then the way you work it out is whatever number's here, you square root that one and you put it over 2. So it's a square root of a number over 2. So let's just fill this in now. So x equals, the sine of 45 is a square root of 2 over 2. Sine of 45 is that one. So x equals, not x equals, x square root of 2 over 2 equals 8. And the sine of 60 is a square root of 3 over 2. Square root of 3 over 2. So we can multiply as a simplified set as well. So we can get rid of these 2's off the bottom, multiply both sides by 2, just makes that disappear, and then you can divide this side by root 2, so x equals 8 root 3 over the square root of 2, so just dropping that underneath. Now to simplify the third, we just get rid of this root 2 by multiplying both sides by root, top and bottom by root 2, so that's going to give me 8 square root of 3 times 2 is 6, so we can square root these things. Over, and square root of 2 times square root of 2 is 2, and then finally 8 divided by this regular 2 is just going to be 4 root 6. Okay, and well, that's it, 4 root 6 to finish with. wonder how many mistakes I made. Please have a look, let me know, and then I'll just be embarrassed. Okay, bye now.